Okay, let's take a look at a problem for our virtual review about perimeter and area. Of course, we took a look at measurement in this chapter, so two different types of measurement, of course, that are common in the elementary grades are perimeter, which of course is a one-dimensional measurement, and area, which is a two-dimensional measurement. So a nice problem to sort of illustrate the difference between one and two-dimensional measurements. So let's try to find the perimeter first. So we're given a figure that looks like it's the composite of a rectangle with two right triangles and another rectangle on top. So let's try to find the perimeter first. You can see that this is 11 and this is 5. Well, if this is a rectangle, then of course we have a 5 centimeter distance here as well. We don't exactly know what this length is, but we're given this length is 3 and this length is 4. So to find this particular length, what we would do is take this side of the triangles, the rectangle's length 11 and take away 3 and 4. So 11 minus 3 minus 4 would be the same as 11 minus 7, or just 4 centimeters there. And since this, of course, would be a rectangle, we can go ahead and take that, translate that up to here as 4 centimeters. And the only thing we're really left with are these two pieces, which of course are hypotenuses of right triangles. So we're going to have to do a little bit of work with the Pythagorean theorem to try to figure out what this length is and this length is. So let's go ahead and do that. The first one we notice for this length, if we call it x, we know that then that guy's length is 2 squared plus 3 squared equals x squared. So 4 plus 9 equals x squared, or 13 is equal to x squared. So what would we have? We would have the square root of 13 equal to x. And on this side, again, we're going to have to do some work with the Pythagorean theorem to find out what, let's call this y. Again, it's going to be 4 squared plus 2 squared equals y squared. So that's 16 plus 4 equals y squared. 20 equals y squared. So the square root of 20 is equal to y. So if we wanted to find the perimeter then of the figure, what we would do is simply add the distance around it. So the perimeter is going to be, let's go ahead and start from this corner and go in a clockwise sense. So it would be 5 plus root 20 plus 4 plus root 13 plus 5 plus 11 centimeters. I can see that I have some like terms here in terms of integers. So 5 plus 4 is 9. 9 plus 5 is 14. And 14 plus 11 is going to be, let's see, 14. 24, 25. So the perimeter seems like it's 25 plus the square root of 20 plus the square root of 13 centimeters. And of course, many of you asked me this today in class, would you prefer in this form or in decimal form? That's entirely up to you. Since it was never stated in this particular problem what form, you can certainly simplify this to a decimal approximation. So that would be our answer for the perimeter. Let's go ahead and find the area of the figure then. So how would we find the area of the figure? Well, we notice that there are at least 4 different pieces in the figure. We could chop it up into the 4 pieces given and go ahead and calculate the area that way. So let's go ahead and do it that way. So the area is going to be first the area of the rectangle here, so 5 times 11. And then it would be the area of this little small triangle here, so 1/2 a base of 3, height of 2. Plus the area of, I guess, this smaller rectangle here, so 4 times 2, plus the area of this little triangle here, which is 1/2 base times height, or 4 times 2. So area calculation here would yield, let's see, 55 plus half of 6, or 3, plus 8, plus half of 4 times 2 is 8, half of 8 is 4. And if you look just sort of at the figure, these numbers should make sense to you. Most of the area in the figure is in this rectangle, and indeed that's where most of the area in the figure is coming from. This was the area of this smaller triangle, it's 3, and you would assume this one's going to be a little bit more area than this one because it has the same height but a longer base, so 4 there. And it turns out that this one is 8, and that makes sense too because, of course, if we were to think of this rectangle being repeated over here on this, I guess with this triangle drawn inside it, and the triangle should be half of the rectangle, and indeed it is. So here we go, 55 plus 3 is 58. 58 plus 8 is going to give us, what, let's see, 66. 66 plus 4 is going to give us 70. So it looks like it's 70 centimeters squared for our area calculation.